Good day, viewers all over the world. I welcome you to my class today on interpolation. It is good having you around today. We shall be looking at interpolation. This is one of the topics we have in numerical analysis. We shall be saying how we can solve problems on interpolation in this particular class. So I want to encourage you to be patient, watch this video to the end, and at the end you will see how you can create a function from a set of tabular values of x and y. Once again, my name is Dr. Chris Esekaibe. I welcome you to my YouTube channel today. Please subscribe to my YouTube channel, like my videos, share them on your social media platforms. You can contact me for research on numerical analysis. I'm a consultant in numerical analysis, data analysis, and modeling. I hold a BSc, a bachelor's degree in statistics, and a master's degree in mathematics, and a PhD in mathematics with distinction. Like as I said, I specialize in numerical analysis, data analysis, and modeling. You can also consult me for your statistical research, statistical analysis. And please, if you have any challenge in any topic, any of the topics in these areas, you can as well consult me. Then I will give solution to whatever the problem is in this area. I am a chief lecturer in one of the prestigious polytechnics in Nigeria. I have university lecturing experience. I also lectured in an A-level college in Nigeria where I taught OSS, the Ontario Diploma Mathematics, and I produced students with grade A. And I also taught in Cambridge A-level Mathematics where I also produced students with grade A. I also taught in the IFG, the International Foundation Group with the UK, and I also produced students with grade A in an A-level institute or college in Nigeria, a pre-university college. So I've also lectured in an open university. So from what I'm giving to this channel is from my wealth of experience. Here is my contact. You can reach me on this contact +234 8033 21903. It's also my WhatsApp number. Also, you can call or reach me on +234 7066297535. And this is my email address, chrisdavid2015@gmail.com. So try as much as possible to reach me. If you are a research institute or an AI institute, I can be part of your institute. We can develop advanced mathematical models or algorithms for artificial intelligence. So you can consult me for such, and I will be glad to be part of it. I live in Nigeria and I work in Nigeria. So it will be a privilege to be part of what you are doing across the globe. On AI, I want to be part of those developing advanced mathematical algorithm models for artificial intelligence. You can call me, you can contact me. Why not work together as a team? So thanks again for watching my videos and subscribing to my YouTube channel. Today we shall be looking at interpolation. Interpolation is a very vital topic in numerical analysis. It's a very vital topic. So before I go further, permit me to clean the board. I believe you have gotten the contact and my email address, so you can reach me so that we can talk about your research institute, your job on AI, on artificial intelligence, your research in numerical analysis, your in data analysis and modeling, and statistical analysis and whatever you have in these areas I have mentioned. Thank you very much for your patience. Now let's go to the business of the day. Please watch me carefully as I take this step by step, and I believe you will not regret the time you spend with me. Now, if this is a function, it's an explicit function. Now when you are given a set of data as this, x naught, y naught, comma, x1, comma, y1, comma, x2, comma, y2, down to xn, comma, yn. These are tabular values of x and y. When you are given these tabular values of x and y, and they are to satisfy, or they are satisfying a relation or a function which is a function of x, these tabular values are satisfying this particular function f of x. Where f of x is not known, this particular function is not known explicitly. So the way forward, we can use interpolation to get a similar function. We can get a similar function which is known as phi of x, and when we get that function, the similar function or simpler function, we assume it to be phi of x. It will definitely be in agreement with f of x. So carrying out this process is what we call interpolation. Carrying out this process is what we call interpolation. Now when phi of s is a polynomial, it is called a polynomial interpolation, and the phi of s itself is called the interpolating polynomial. It's called the interpolating polynomial. So before we carry out this the process of looking for this function that is not explicitly known, represented by phi of x, we need to know what we call the forward and backward, backward difference operators. Now, without the forward difference table, creating a forward difference table or a backward difference table, it will be pretty difficult to carry this out. So the forward difference operator is known as this. This one is for the forward difference operator, while the one pointing downward is for the backward difference operator. So we need to create a backward difference and so on and so forth. For instance, if I have a table as x and y, for instance, maybe these are my x naught, x1 down to xn, and this is my y naught, y1 down to yn. Now if I'm to create a forward difference, that's what they call, this is the first forward difference. This will simply be y1 minus y naught, and of course if there is y2 here, the next one will be y2 minus y1 down to yn minus yn minus 1. It goes like that. Then before you know it, you create a second forward difference table, and you begin to go like that and like that. By the time we pick an example, we should be able to carry out or solve one or two problems on interpolation. And there is no way we can achieve this without looking at the Newton's forward and backward difference interpolation formula. We are not going to go into the derivation of these formulae. What we are going to do, we are just going to apply them directly to solve problems. Trying to derive them will be a job for some other day. But for today, we shall be applying them. Now let us look at the Newton's forward difference interpolation formula. Newton's forward difference interpolation formula. Now, using this Newton forward difference interpolation formula, we can get a value for our f of x, and the formula is given to us: y of x subscript n is equal to y naught plus p forward of y naught plus p into p minus 1 into the second forward difference of y naught all over 2 factorial, and it goes like that, plus p into p minus 1 into p minus 2 into the third forward difference of y naught all over 3 factorial, then plus p into p minus 1 into p minus 2 into p minus 3, then the fourth forward all over 4 factorial. It goes on like that, and so on and so forth. So this is the Newton's forward difference interpolation formula. This is how it works. Then you need to know that your p is given as, the value of p is given as x minus x naught all over h. Our h is the step length for x. It's given as x minus x naught all over h. So we need to take note of this formula. From here, if I want to get the value of x, for instance, I will have it as, of course, x minus x naught is equal to ph. So my x will be equal to x naught plus ph. So you take note of that particular formula. Now, we want to look at a particular example. Let's call it example 1. Find a cubic polynomial which takes the following value. Find a cubic polynomial which takes the following values. The first one is y of 0 is equal to 1. Then the second one is y of 1 is equal to 0. Then the next one is y of 2 is equal to 1, and y of 3 is equal to 10. And the question continues. It says obtain y of 4. So you obtain the value of y when x is equal to 4. So taking a look at this problem, the first thing we need to do is to create a table. The forward, now the solution. Creating a forward difference table. That's the first thing we are going to do. So we have to create a table of x and y. Now you can see the function is a function of x. Note our y is a function of x. Now the values in bracket are the values for x. So the first value inside the bracket here is 0. The next one is 1. the next one is 2, the next one is 3. Then the right hand side will be the value for y. So when s is 0, y is 1. When s is 1, y is 0. When s is 2, y is 1. When s is 3, y is 10. So now the set of problem, or this particular problem, has a fixed value for h. H is the increment of the values of x. So for this particular problem here, our h is equal to 1. Look at it now. S is increasing with 1, from 0 to 1, 1 to 2, 2 to 3. Then somebody may ask a question: what if the increment or the differences in the values of h is not uniform, it's not the same? What do? We will come to that particular one. We are going to take an example for solving that kind of problem when we get there. But for now, we are looking at a situation where our h is fixed. Here our h is 1, and h is gotten from the x column. You can see between 0 and 1 is 1, between 1 and 2 is 1, between 2 and 3 is 1. So, but now creating the forward difference table, we make use of the y column. So we are going to get our first forward difference, 0 minus 1. You put it at the middle. 0 minus 1 is minus 1. 1 minus 0 is 1. 10 minus 1 is 9. Then you go again to create the second forward difference column. 1 minus minus 1, you put it at the middle, is 2. 9 minus 1 is 8. Then you go again to create the third forward difference column. Then you now get 8 minus 2 is 6. You put it at the middle, then you stop. This is how we get the forward difference table. Now, since we have gotten the forward difference table, please take note of the problem. You can see it. We are trying to get a cubic polynomial. You can see now, how do we know that it's going to be a cubic polynomial? Look at it now. It stops at third forward difference. The difference table stops at third forward difference, so it's likely to be a cubic. If it stops at 4, it's going to be a quartic. That means it's going to be a polynomial of degree 4. But now that it's cubic, it's going to be a polynomial of degree 3, which is a cubic polynomial. If it stops at 2, it's going to be a polynomial of degree 2, which is a quadratic polynomial, and so on and so forth. So you need to note this. If it stops at the fourth forward difference at 6, it's going to be a polynomial of degree 6. Now, having this, it is good we now know the value of p. Okay, if we now come here, what do we use to represent p? This is how it goes. Now look at it now. From here, x is equal to this, and now what is our x naught? Our x naught is the starting value, the first value of x. You remember, it runs from x naught to xn, and also from y naught to yn. So our x naught is 0. So here our x naught is equal to 0. So putting it into this, please note that your x is different from your x naught. So your x will now be, what is our x naught? 0 plus, now we are now trying to look for the value of p in form of x. So with this will be p. Now our h is 1. So 1 times p is p. 0 plus p is p. So our x is equal to p. So wherever we see our p, we can put the value of x there. So x is not the same thing as x naught. X is not the same thing as x1, and so on and so forth. So permit me to claim this part. To take note, our x is equal to p, our h is 1, and the formula still remains there. So permit me to claim the problem why we use this Newton's forward difference interpolation formula to get our cubic polynomial. So let me claim this, the question, so that we can remember we are to obtain y of 4. It means you obtain the value of y when x is equal to 4. Obtain the value of y when x is equal to 4. Please This is 4 factorial. I hope you understand what we mean by factorial. If I say 3 factorial, it means 3 times 2 times 1. If I say 5 factorial, it means 5 times 4 times 3 times 2 times 1. Now, you can see now the highest forward difference here is the third forward difference. So that means our n here is 3. Look at it, x0, x1, x2, x3. So the highest value of this thing there is n. So this will be y of x to 3. So this is now equal to, look at our y0. What is our y0? Y0 is the starting value of y. This is y0, y1, y2, y3. So the polynomial is of degree 3 and it's a cubic polynomial. So y of x to 3 will be equal to y0 is 1. You put your 1 plus, remember our p is equal to x. Our p is equal to x. We showed how we got that. So this will be p, which is x into, now what is the first forward difference? The first forward difference here is -1. You put it here, -1. Then you put your plus sign. Then p is x into p is x minus 1. You have that. That is p minus 1. Then the second forward difference is 2. So you put it in bracket 2. Then this is all over 2 factorial. 2 factorial is 2 times 1, which is 2. Then again you come plus, this one is, our p is x into p again is x minus 1 into p minus 2 is written as x minus 2. Then the third forward difference at y0. From y0 you can see y0 is 1. So you are taking the first values all through. So that will be 6. That's for the third forward difference. The value is 6 from the table all over. Remember your 3 factorial is 3 times 2 times 1, which is also 6. You can see that this 6 we cancel out this 6. This 2 we cancel out this 2. So taking out the opening the brackets and taking out like terms, you have y of x into 3 is now equal to 1x. 1x times minus 1 is minus x. Then of course these 2, we cancel these 2. If you open this, you are going to have plus x squared. X times x is x squared. X times minus 1 is minus x. Then when you open up the bracket there, you are going to have plus s cubed minus 3x squared plus s cubed minus 3x squared plus s cubed minus 3x squared plus 2x plus 2x. So when you take the like terms and cancel out, you are going to have your y of x to the total to be x raised to power 3 minus 2x squared plus 1. So this is our cubic polynomial that fits the particular set of data or the data point given. Remember, we are told to obtain y of 4. So y of 4 simply means the value of x to be 4. So this will be 4 raised to power 3 minus 2 into 4 squared plus 1. 4 raised to power 3 is 64 minus 4 squared is 16. 16 by 2 is 32 plus 1. The answer is 33. So our y of 4 is equal to 33. You can see how we can use this to now predict or forecast for values of y. You can see we can also forecast for the value of y when x is 5, when x is 6, and so on and so forth. So you can see how beautiful interpolation is one beautiful part of interpolation in numerical analysis is that it helps us to forecast values. It helps us to forecast values. So this is how we have been able to use the Newton's forward difference interpolation formula to solve this. There is a backward difference formula also. The difference between the backward difference formula is that this p minus 1, p minus 1 plus 2, p minus 1, p minus 2, they are all p plus. Those negative sign will be turned to positive sign. The reason is that if I say 3 minus 2 is equal to 1, if I now say 2 minus 3 is equal to minus 1, so the difference is the sign. So the Newton's backward difference interpolation formula has plus sign all through instead of negative. That's just the difference between the forward and the backward difference formulae for Newton's interpolation. So this one will not be plus, 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 where you are saying p minus, you now turn to p plus, and so on and so forth. That's just the difference between the backward and the forward difference formulae. So I hope you have gotten this now. Now somebody may ask, or someone may ask, say, what if in a situation we are faced with a problem where the value for h is not the same, it's not fixed. Like here now, h is 1, it's common. 1 minus 0, 1, 2 minus 1, 1, 3 minus 2, 1. What if you have a situation whereby the difference between the x0 and the x1 is 2, the difference between x1 and x2 is 4, the difference between x3 and x2 is 8, like that. There is no h anywhere. So what do we do? So this will now result to what we call the Newton's general interpolation formula. So now let us go ahead and see the Newton's general interpolation formula. This formula is also called the divided difference formula. It is also called the divided difference formula. So we'll see this formula, you can use it to solve a problem where h is fixed, and you can also use it to solve a problem where h is not fixed. So we are looking at the Newton's general interpolation formula. So we also call it it's called the divided difference formula. So this is another name for the Newton's general interpolation formula. Now the essence of this is as a result of a situation whereby h is not fixed. The value for h is not the same across the various values of x that we have. Now, like I told us from the beginning, we are not deriving the formula, we will just go straight to applying it. So the Newton's general interpolation formula, which is also known as the divided difference formula, is given as y is equal to y naught, or you can call it y of x n is equal to, okay, let me write it neatly, y of x n is equal to y naught plus you have your x minus x naught, then there's a difference between the bracket and the bracelet, then here you have your x naught comma x1 in bracelet plus I will explain that x minus x naught into x minus x naught into x minus x minus x1 into bracket, then the bracelet will now take from x naught, x1 and x2, x naught, x1, x2, you close the bracelet, then plus x minus x naught into x minus x1 into x minus x2. Then that will now be into the brace will now be x0, comma, x1, comma, x2. It keeps going like that. Then you can come and say plus x minus x0 into x minus x1 into x minus x2 into x minus x3. Then you open the bracelet, x0, x1, x2, x3, then plus, it keeps going like that. So this formula is very easy to apply, and this is the Newton's general interpolation formula, also known as the Newton's divided difference formula. The ones in bracelet are gotten from the divided difference table. So you will create a divided difference table for you to know how to use this Newton's general interpolation formula. The value of h notwithstanding, if there is a fixed h, this formula can handle it. If h is not fixed, the formula can handle the differences in h. So that is what it stands for. So now we are going to get an example. We can call this example 2 for this video. Certain values of x and log x to base 10 are given below. Certain values of x and log s to base 10 are given below. You have 300, 2.4771. Then you have 304, that is 2.4829, 2.4829. You have 305, log 305 is 2.4843, 2.4843, and last one we have 307, and the log of 307 to base 10 is 2.4871. 2.4871. Now find, the question is find log 301 to base 10. That is the question. So if you take your calculator and press log 300, you will get this to 4 decimal places. You will get 2.4771. If you press log 304 to base 10, you will have 2.4829. If you press log 305 to base 10, you have 2.4843. And you press log 307 to base 10, you will have 2.4871. Now the question, using interpolation, how do you now get the value for log 301 to base 10 without using your calculator? So you can see that numerical methods are dependable, they are reliable, and they are very efficient. Most especially in cases where you cannot reach the conventional method to solve a particular problem, a numerical approach will be very useful and helpful. So now, let us get the solution. The first thing we need to do is to create, look at the values of x now. It is given, this particular problem is given in this format, x to log x to base 10. Just like x, y. Now the first thing, and look at the first value of x here, 300. The next value of x is 304. The next value of x is 305. The next value of x is 307. There is no fixed h there. The difference between 300 and 304 is 4. The difference between 304 and 305 is 1. The difference between 305 and 307 is 2. So there is no fixed age. Hence, we can use the divided difference formula by Newton. So hence, we create a divided difference table. So that is what we are going to create. So now we'll come here and create a table of x and y. The first value of x here is 300. The next one is 304. The next one is 305. While the last one is 307. So this is what we have. Now we are going to put the corresponding values of y. For 300, we have 2.4771. For 304, you have 2.4829. For 305, you have 2.4843. Then for 307, you have 2.4871. You have this. Then now we are going to create what we call the divided difference table. The first forward divided difference table is written in this format. And now, how do you get that? You say 2.4829 minus 2.4771. You will get a value. Then you will now divide it by the difference of 304 minus 300 is 4. So you divide this difference by 4. And when you divide that difference by 4, you are going to get 0.00145. I come again. It will be 2.4829 minus 2.4771. The answer you get, you divide it by the difference. You can see here there's no fixed age. 4 minus 300 is 4. 304 minus 300 is 4. 305 minus 304 is 1. 307 minus 305 is 2. So you divide each difference by the differences in x. So 2.4829 minus 2.4771, you divide it by the difference between 304 and 300. Divided by 4, you will get this. Then the next one will be 2.4843 minus 2.4829. You divide it by the difference of 305 minus 304 is 1. Well, of course, when you divide it by 1, it remains itself. So you are going to get 0.0014. Then the last one, 2.4871 minus 2.4843. You get a value there. The difference between 307 and 305 is 2. When you divide that difference by 2, you are still going to get 0.0014. That's what you are going to get. That's the first forward divided difference. Now we want to get the second one, which is the second forward divided. This one is division sign, divided difference. Now look at this. Listen carefully, you will get this. What produced this 0.00145? It is these two values from between 300 and 304, and between 2.4771 and 2.4829. That's what produced this. Now what produced this second value here? It is 0.0014. What produced this value here is, what produced 0.0014 is this 2.4843 and 2.4829, and the difference is this. So now, if I want to get the difference between these two, it means I will take the difference from this point to this point. These two values were produced from this point to this point. That's what produced it. That's what produced the two values. So if I now come, if I say 0.0014 minus 0.00145, I will have an answer. I will have minus 0.00005. Then now what am I going to divide it with? what produced these two, I said, is from year to year. So the value for x is between 300 and 305. So it will now be 305 minus 300, it will be 5. So you are going to divide this difference by 5. You are going to get minus 0.00001. That's what you are going to get. I come again. What produced these two is from this 300 to 305, from this first one to the third one, from x0 to from y0 to y2. So you are going to take the difference between 305 and 300 to divide it. That's why it is called the divided difference table. Now, if you come to this one, of course, again, if you come here, what produced these two is from year to year. You see it? From year to year. That's what produced these two. So the main thing here is that this minus this, of course, will give us 0. But if peradventure the difference is not 0, what gave birth to this two, or what produced these two, is from this second value down to this value. So if peradventure the difference between, now you can see the difference between this and this is 0. 0.0014 minus 0.0014 is 0. But if peradventure it is not 0, what are you now going to use to divide? Now, what gave birth to this first one is this 2. What gave birth to this last one is this 2. So the difference you are going to use is from this to this. So you are going to divide by 307 minus 304. That is how it works. So if you go now, of course, because this one is 0, when you divide 0 by, of course, 307 minus 304 is 3. When you divide 0 by 3, you still get 0. So this will be 0.0000, and so on and so forth. So that is where we are going to, because if you take this minus this, of course, you arrive at the last value there. So we have this. Then we are going to find log 301 to base 10. So this is how, if you want to move forward, of course, if it's okay, let us go ahead and get the third forward divided difference. Of course, if you see this minus this, and of course, again, if you, what gave birth to this? Look at it. What gave birth to this is from year to year. What gave birth to this is from year to year. So you are still going to divide by 7. 307 minus 300 is 7. So you divide and you go on. Of course, it will be 0.0000. It's a huge, and this is approximately 0, because we are working up to 4 decimal places. So you have the right to stop here. But if peradventure you want to move forward, you say 0 minus this, it will be minus will turn to plus. It will be 0.00001 divided by what? What gave birth to this is this 3 from year to year. From year to year gave birth to this, that is from 300 to 305. What gave birth to this is from year to year, that is from 304 to 307. So the value you are going to use to divide it will now be 307 minus 300, which will be 7. Of course, if you divide that by 7, 4 decimal places, you are still going to have 0. So there is no need for that. So what we need to do now, permit me to clean the board. Of course, the problem itself, the formula will still be there, so that we can use the formula. Let me clean it so that we can apply the formula directly. Like as I said, we are dealing with application. We are not dealing with derivation. So when you know how to apply, then of course the derivation is not going to be too cumbersome. Now let us go ahead. Log 301 to base 10. Now let us use the formula. Look at it. Here is, let's remove the y. Here is y0. Our y0 is the first value there. That will be 2.4771. Then plus. Now remember, our x here is 301. The x we are looking for, x is 301. X is equal to 301. That's what we are looking for. So that is the value of x. Now this will be x minus x0. What is our x? Is 301 minus our x naught is 300, the first value of x, minus 300, bracket open close. Now the first bracket bracelet here, note the difference between the bracket and the bracelet. The first bracelet here talks about the values from the divided difference table. So this is the first one, which is into 0.00145. You close it. Then again, you go to the next one, you put your plus sign. Our x is 301. This will be 301 into minus x naught, minus 300. Our x naught is 300. Our x1 is 304. Then of course again is x, which is 301 minus x1. Our x1 is 304 minus 304. Then of course, before you now have the divided, the value from the divided difference table, and that will now be into minus 0 point, which is the second one, 0.00001. So when you now have that, you now have your log 301 to base 10 to be equal to 2.4771 plus, of course, 301 minus 300 is 1. 1 multiplied by this value, it will be plus 0.00145. Then, of course, 301 minus 300 is 1. 301 minus 304 is minus 3. So you put your plus bracket minus 3 into this value into minus 0.00001. Then you have that. Then when you carry out this arithmetic, you are going to have 2.4786. 2.4786. Remember, the minus here will become plus. So that is what you're going to have. Now, if you want to check how reliable these numerical methods can be, you can easily press your calculator and check the value of log 301 to base 10. You are going to have that value 2.4786. And if you check all these values, of course, your y is equal to log x to base 10. That is what your y is. It's log x to base 10. So you can see how reliable these numerical methods can be. Using the Newton's general interpolation formula or the divided difference formula, we have been able to solve a problem that is not up here. You don't need your h. Like the forward and the backward difference formula, you will need your h. So this Newton's general interpolation formula can solve any type of problem on interpolation. Whether the values of h are fixed, there is a common value for h, or whether there is no common value of h. Like this one that has the h is not common. 304 minus 300 is 4. 305 minus 304 is 1. 307 minus 305 is 2. And so on and so forth. So we have been able to create, if you can successfully create a divided difference table and you apply the formula correctly, you are very sure to get the right answer. You are very, very sure to get the right answer. So beloved, you can see how far we have gone today. We have been able to use the Newton's forward difference formula to solve a problem and made a forecast. And now we have used the Newton's general interpolation formula, also known as the divided difference formula, to solve a particular problem, and so on and so forth. So please, you watch out for my next video on interpolation part 2. Today's one is part 1. You watch out for the part 2 of it. We shall be solving more problems using the Newton's forward and backward difference formulae, and unlikely we use the divided difference formula also to solve a particular problem. So watch out for the part 2 of this video. I want to really appreciate you for waiting and watching this video to the end. By now you have a proper understanding of what interpolation is and what the Newton's divided difference formula is and what the new things forward and backward difference formulae are. So please watch out for the next video, the part 2 of interpolation. Like as I said from the beginning of the video, my name is Dr. Chris Esekaibe. I'm a chief lecturer in one of the prestigious polytechnics in Nigeria, where we teach our students, we impart them with knowledge for advancement, knowledge for creativity, knowledge for invention. I'm a member of the Nigerian Mathematical Society and also the Statistical Association of Nigeria. I have quite a number of publications, national and international, and I've presented papers in various conferences within and outside Nigeria. Like as I said, my contacts were displayed at the beginning of this video. Please take my contact. If you have any research on numerical analysis, you can contact me. You can send me an email or a WhatsApp message. Contact me on numerical analysis, data analysis and modeling, mathematical analysis, even for your statistical research. Contact me and I will be glad to be of help. And if you are a research institute or an AI institute, why not you can also contact me so that we develop advanced mathematical models or algorithms for artificial intelligence. I will be glad to work with you. I live in Nigeria and I work in Nigeria. Just send a WhatsApp message or an email, it will be attended to. God bless you. Subscribe to my YouTube channel. Click on the bell button for notification. Anytime I upload a new video, you will get a notification. Like my videos, share them on your social media platform, and as you do, God will bless you. Enjoy the rest of the day as you wait for my next video in our next class. Bye.